All right, let's take a look at this domain and range worksheet. Start out with our review problems. Write the equation in the slope-intercept form of the line perpendicular to 3x plus 2y equals 12, passing through that point. So first of all, we'd want to know what the slope of this line is. If we solve that to make it look like 2y is negative 3x plus 12, then y is negative 3 halves x plus 6. So the slope of this line is negative 3 halves, which means the slope of every line that's perpendicular to it is positive 2/3. So using the y minus y1 equals m times x minus x1, our point slope form, that's going to look like a y plus 2 is equal to 2/3 times x minus 4. And so we'd get a y is 2/3 x. Let's see, that's a minus 8/3 minus another 6/3, my other name for 2. And so I get an equation in slope-intercept form that looks like y equals 2/3 x. Sorry, this is 6/3 minus 14/3. And that is the equation in slope-intercept form. Okay, writing this as a single logarithm, we see subtraction here, but we have these coefficients out in front that we've got to deal with first. So those can move back up, so this can become a log base 3 of x squared minus the log base 3 of 2 to the 4th power. And now the subtraction can become division, so this is a log base 3 of x squared over 2 to the 4th, which is 16. So could be written as log base 3 of x squared over 16. All right, which of the following of these are not in the domain of log base 7 of 5 minus 2x? Well, we could just try those things individually. 5 minus 2 times 2.5, that'd be 5 minus 5 is 0, and we can't take a log of 0, so this one is not in the domain. If I try to put a 1 in, it's log of 5 minus 2, which is 3. I can do a log base 7 of 3, that's not a problem. If I put a 0 in, it's log base 7 of 5, also not a problem. But when I put a 3 in, I get a 5 minus 6, and I cannot do the log base 7 of negative 1. Logarithms can only take positive numbers on the inside, so that one is not in the domain. Okay, what is the domain of this? Well, the problem, we start by assuming it's all real numbers, but there is a variable in the denominator, so if there's any place where 3 plus 2 happens to equal 0, which happens when 3t is negative 2 or t is negative 2/3, then that is not in the domain. So we could either specify this as t not equal to negative 2/3, we could describe the domain that way. Or if we were using interval notation, it's from negative infinity to negative 2/3 union negative 2/3 to infinity. So it's every number except for that one. All right, since she got her job as CEO of a small tech company, Delilah's salary has gone up 5% every year. Her salary can be modeled by this equation. What is a reasonable domain? Well, this is, T stands for the number of years since she got her job as CEO. So a reasonable domain might start at 0. So that very first year, and I don't know, maybe she got a CEO at 30. At most, I would say 50 years kind of as a maximum there, and then she's probably out of that. A lot of CEOs don't last that long, but so by t equals 50, she is probably 75 plus years old and probably not in the business anymore. It would also be, at that point, you'd be making a fairly insane number there. If I said that 50 was that number, then I could bring my calculator in here and see how much she is making after 50 years according to this formula. So we start out with a 500,000 times 1.05 raised to the 50th power, and that is a little shy of $6 million. So reasonable range, it's going to start at the low end at the $500,000 that she has right now and top out at, we'll say, $6 million. 1, 2, 3, 4, 5, 6. These are the values from the equation for the given domain. Okay, or the reasonable domain that we assumed there. Okay, these are certainly not exact. These are implied by the problem, and those are reasonable numbers to use. What are the domain and range of this graph? So if we're looking at the domain, we're looking at what x values can I use. There doesn't seem to be anything to the left of -6, but I can use a -6. So I'm going to square bracket -6. And all of these values from -6 up to 2, but the 2 has open circles on both parts of that, so it can't include the 2, but then it can pick up on the other side of the 2, and it looks like it then stops abruptly at 4. So domain comes from the inputs. Our range on this one is going to be the outputs, and we start kind of from the lowest numbers, which are down here at the negatives. That looks like about -1, where that point is there. And I can get all of the values from -1 up to 4 out of this. I don't think there is any output value that I can't get. Okay, they seem to all be covered in there. And then finally, off the graph here again, this shape, I recognize this as there being a vertical asymptote there and a vertical asymptote here. Okay, it's familiar for that particular shape. And so, and I also have a horizontal asymptote, it looks like at about 1 here. And then this hits my axis right there. So my domain, the numbers that I'm allowed to use, we've got arrowheads on these things indicating that that goes forever that direction. So from -infinity up until I get to this point, which is at -2, I can't use the -2. I can pick back up at the -2 and go to 1. But I can't use the 1. I can pick back up at the 1 again and continue on to infinity. So that is my domain. I could also express that as x cannot be equal to -2 or 1. Okay. My range on this one, it looks like these have arrows that go down forever, so I can get from -infinity up until it looks like I hit 0, and I can actually hit that 0, and then there's a gap. And there is a gap, and things pick back up at 1. It's not going to get all the way down to 1 at that end behavior of a horizontal asymptote, but it can hit all of the values above that. And so my range would look something like that.